Section 3.1, solving quadratic equations. In chapter 2, we talk about, graphing and transforming and writing equations or functions of quadratics. In chapter 3, we get into the other side of quadratics, and that would be solving quadratic equations. Okay, so for the majority of the chapter, we're going to be working with a quadratic equation in one variable. Okay, that's an equation that can be written as ax squared plus bx plus c equals 0. And the key here is it's got to be equal to 0. Okay, so the answers that we're going to be looking for are called roots. Okay, so just a solution of the equation. And there's three different ways that I'm going to highlight in section 3.1 that three different ways that we're going to use to find the roots or find the solutions of these equations. This video is going to go through method 1 and method 2, and then the second video is going to cover method 3. Okay, so method 1, solving by square roots. Square roots only works when there's only an x squared term. So if we go back to the first page, if there's a bx and an ax squared, then square roots isn't going to work. We'll have to use one of the other two methods. But if there's no bx term, okay, then we can use method 1, which is solving by square roots. Okay, so let's just jump right in. Number 1, 4x squared minus 100 is equal to 0. Okay, now I know I just said that it's got to be equal to 0 in order for us to solve. If we're going to use square roots where we just have an x squared term, notice we don't have that bx, we don't have just an x, we just have x squared. If it's just x squared, we don't necessarily need it to be equal to 0. Okay, the goal here at first is to get x squared by itself, or instead of by itself, maybe we could say alone. Okay, we want to get x squared alone. So the first thing we need to do is get rid of the 100. We'll do that by adding. So our steps are going to be just the same as if it was linear, like if it was 4x minus 100, but now it's 4x squared minus 100. So 4x squared is equal to 100. Then we'll divide both sides by 4. That leaves me with x squared equals 25. Okay. Now, how do we undo this square? How do we undo squaring something? And that's where square roots comes from, or comes in. We're going to undo squaring by taking the square root of both sides. Okay, so when we do that, we're left with x. The square root and the square cancel each other out. Then we got to think about, what number multiplied by itself gives you 25. And there are actually two answers. Positive 5, because 5 times 5 is 25. But there's another one. There's also negative 5. Negative 5 times negative 5 is also positive 25. So rather than writing 5 and negative 5, rather than writing out twice, there's a shorthand. We can write plus or minus. That stands for that. What this means is that x could equal positive 5, or it could equal negative 5. Okay, when we're taking the square root of a number, if we're solving and we're finding the square root, we've got to have plus or minus, because positive numbers have two square roots. Let's try another one here. Number 2. Let's go with negative 9x squared plus 36 is equal to 0. Okay, same thing. We've got to get x squared by itself. We'll do that by first subtracting 36. So we've got negative 9x squared is equal to negative 36. Scroll that up. We'll get rid of the negative 9 by dividing. We've got x squared is equal to, let's see, that's positive 4. Negative divided by negative is a positive. And then again, we'll get rid of this square by square rooting it. So that leaves me with x on the left. Two numbers multiply together, they get multiplied by itself to get to 4 would be positive or negative 2. Okay, so those are a couple basic examples with solving with square roots. There are more complex, and we'll get to those in a little bit. Okay, but I do want to talk about the properties of square roots. There's two properties that we need to discuss. The first one is the product property. And what the product property says is that if we have the square root of a product, so the square root of a times b, what we can do is we can split that product into two separate square roots, the square root of a times the square root of b. Similarly, we have the quotient property. And what the quotient property says is that if we have the square root of a fraction, or a quotient, square root of a over b, we can break this into two square roots again, the square root of a over the square root of b. So the question then becomes, well, why do we have these? Okay, that's where simplest form comes in, because sometimes our answers aren't going to look like this, where we get plus or minus 2. Okay, we might get something where we have to actually leave our answer with a square root in it. Okay, and if we have to do that, we want to write our answer in simplest form. And what simplest form means is that we're not going to have any radicals in the denominator, so our bottom isn't going to have any square roots, and I'll show you how to deal with that if you get an answer that looks like that. And we're going to have no perfect square factors, so this number wouldn't be able to be simplified any farther. Okay, so let's go ahead and try simplifying. I've got 6 examples here for you, so just bear with me. They'll get progressively harder. So we're going to start with the square root of 45. Now, 45 is not a perfect square, okay? Before we actually do this, let's go back and let's actually list the perfect squares. That might be a bit of a help. So let's start x, and we'll go x squared. So 1, 2, we'll just list the first, maybe 12, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so 1 squared, that's 1. 2 squared is 4. 3 squared is 9. 4 squared, 4 times 4 is 16. 5 squared is 25. 6 squared is 36. 7 squared, 49. 8 squared is 64. 9 squared is 81. 10 squared, 10 times 10 is 100. 11 times 11 is 121. And 12 squared is 144. And I'll have a nice little handout for you that outlines the perfect squares along with the perfect cubes, perfect fourth powers, fifth powers, and I believe it even has 6 powers as well. But for now, we're just working on the perfect square. So these are the numbers that are going to be vitally important to simplifying square roots. Okay, so let's go back. Square root of 45. Obviously, 45 is not in our chart. It would be right in here, but it's not a perfect square. Then the question becomes, is it divisible by 1? Can we write it as a product of a number, 1 being this one would be a perfect square, this one might not be. 45, if you go back to your table, 45 is divisible by 9. Okay, that would be 9 times 5. Okay, and then what we can do with that is we can break this down into the square root of 9 times the square root of 5. The square root of 9 is 3. Now notice, when you actually take the square root symbol, this little check mark thing, this thing, that goes away. It's just 3. It is not the square root of 3. Okay, I want to make that very clear. That mistake has been made plenty of times in the past. Do we know the square root of 5? The answer there is no, but we can leave it as the square root of 5. So 3 times the square root of 5 would be your final answer. Now, when you do these steps, do you need to go from here, then to here, then to here? No. If you want to go from here just to show me that you're splitting it into something that is a perfect square times something else, and then going right to here, I am perfectly okay with that. That's probably what I'm going to do from here on out. Okay, so this step right here is a little unnecessary, but I'm just showing you the steps behind it. So, number 2, how about the square root of 242? I'm going to tell you right now that 242 is not a perfect square, but it is divisible by 1. The one that it's divisible by is 121. Okay, 121 times 2 is 242. Now, could we pick a different number to divide 242? Sure, but the key is we need this one to be a perfect square, or this one, doesn't matter. One of these two numbers has to be a perfect square in order for this to work. Ideally, we'd want to use the biggest one possible. If there were smaller ones, you would have to keep going with whatever number you came up with here, for example. Okay, so the square root of 121 is 11. The square root of 2, we do not know what it is, so we'll just leave it as the square root of 2. So 11 times the square root of 2 would be your answer for number 2. Number 3. Let's try another one here. The square root of 112. Now, 112, let's see. 112 is divisible by 4, but that's 4 times 28, and 28 can be broken down even farther. So while 112 has several perfect square factors, we want to choose the biggest one. And the biggest one here is, in this case, 16. Okay, and that would give us 16 times 7. Okay, before I do that, I'm actually going to go back and do the smaller one, because I want to show you what that looks like. Okay, so if we use 4, let's say you can only come up with 4. So we have 4 times 28 gives us 112. Okay, so the square root of 4 is 2. Square root of 28, well, we don't know what it is. Okay, but 28 can be broken down even farther. Okay, so we'll have 2 square root of, we can break 28 down into 4 times 7. Okay, the square root of 4, so let's change the colors here again. So we'll have 2 times, again, 2 for the square root of 4 times the square root of 7. You can do 2 times 2 to get 4 square root of 7. Now, had you done it with 16 right away, oops, let me go back to orange here. Had this been done with 16 right away, this would have been 16 times 7, which then it goes right down to that answer. So it would have saved you an extra step had you gotten the biggest perfect square right away. Number 4. Don't think I've forgotten about the quotient property. So now let's do some fractions here. The square root of 13 over 81. Okay, so what we can do, we can use the quotient property, that would be this one here, to split this into 2 separate square roots. So the square root of 13 over the square root of 81. Square root of 13 is not a perfect square, obviously. It's not divisible by one of the perfect squares either, but it's in the numerator, so we have some, so we have some leeway as far as, how we write our answer. So that we can still leave this as the square root of 13. It doesn't have any perfect square factors, so we don't have to worry about breaking that down any farther. Square root of 81 is a nice number, okay? That would be 9. Now, if the directions just say simplify your answer, you do not need plus or minus, okay? The only time you need plus or minus is if you're actually solving an equation, okay? But if you're just simplifying, plus or minus isn't that important, okay? So the square root of 13 over 9 would be your final answer. And be very clear that the square root is only in the top and not in the bottom, okay? Just make that very clear. Number 5. Here, let me slide this up. We got the square root of 196 over 169. Now, we didn't get to those numbers, but 196 and 169 are both perfect squares. Okay, so we can break this into square root of 196 over the square root of 169. Square root of 196 is 14. You can actually find that on your calculator if you don't know that already. The square root of 169 is 13. So really, this one breaks down really easily, 14 over 13. And go ahead and leave it as an improper fraction. That's the best way to write that. Okay, one more here, number 6. This one will be a little more complex. So we got the square root of 9 over 2. All right, so we can break this into 2 separate square roots. Square root of 9 over the square root of 2. We know the square root of 9 is 3, but we don't know the square root of 2. Now, if you remember the definition of simplest form, it says no radicals in the denominator. Well, if you look here, we've got one. So how do we get rid of it? What we want to do is we're going to multiply this fraction by a value of 1. But it's not going to be just like 1 over 1. That's not going to help us. What we're actually going to do is we're going to multiply it by the denominator over the denominator, the square root of 2 over the square root of 2. Because what's going to happen, we're actually going to use the product property now. So we just multiply straight across because we're multiplying fractions. 2 times 2 is 4, so this becomes the square root of 4. 3 times the square root of 2 just becomes 3 times the square root of 2. And then we can actually simplify the denominator now. Now we know what the square root of 4 is. That would be 2. 3 square root of 2, there isn't anything there to simplify. So we just leave it as 3 times the square root, not of 3, silly me, square root of 2. So 3 square root of 2 over 2. We'll do plenty of practice with problems like that. So if you're not real sure right away, don't worry. You'll have plenty of time to get that cleared up. All right. So, oops, sorry about that. Let's go back to solving. So let's try some problems. Now maybe we won't get an answer that has a nice perfect square. So how about 2x squared plus 14 is equal to 70. Now, like I said, since we just have x squared, we don't necessarily need this to be equal to 70, or 0, I mean. But when we get into more complex things, then it will need to be able to equal 0. And it's really not that difficult to make it equal to 0, and I'll show you how to do that a little later. Okay, so 2x squared plus 14 equals 70. We want to get x squared by itself. Okay, so it's the same rules. Subtract 14. That gives me 2x squared is equal to, that's 56. Then we just need to keep going. We'll divide both sides by 2 because we want to get x squared by itself. 56 divided by 2 is 28. And again, to undo a square, we're going to square root both sides. So x equals, now we're solving with, whoops, go back to the pointer here. We're solving with square roots. So now we need plus or minus again. 28 is not a perfect square, but it is divisible by one of the perfect squares, and that perfect square is 4. So we can rewrite this as 4 times 7. The square root of 4 is, so we need plus or minus again. The square root of 4 is 2. Square root of 7, we don't know what it is, so we leave it as the square root of 7. But it doesn't have anything else that's divisible by that can be broken down even farther. So plus or minus 2 square root of 7 is your final answer there for number 1. Let's try another here. Number 2. 4x squared minus 31 is equal to 49. Okay, again, same rules. Get x squared by itself. Plus 31 plus 31. 4x squared is equal to 80. Divide both sides by 4. X squared is equal to 20. Slide this up here. We need to square root both sides now to undo the square. So x equals, again, we're solving with square roots, so we need plus or minus. 20, not a perfect square, but it is divisible by 4, just like the last one. So we can make that 4 times 5, not 4.5. 4 times 5. Square root of 4 is, square root of 4 is 2, and then we have the square root of 5. So 2 plus or minus 2 square root of 5 would be your answer for number 2. Let's try another here. Number 3. Let's go with 3x squared plus 9 is equal to 0. So this one's equal to 0, but it's still the same rule. So we want to get x squared by itself. So minus 9, 3x squared is equal to negative 9. Divide both sides by 3. X squared is equal to negative 3. Now, when we square root, if you try to take the square root of negative 3 in your calculator, you're going to get an error. It's not possible. So think about what we're trying to do. We're trying to take a number times itself and get a negative number. So if we take negative 3 times negative 3, we get positive 9. If we take positive 3 times positive 3, we get positive 9. If we take positive 3 times negative 3, we would get negative 9. And obviously this is negative 3, but it's the same idea. But then it's not the same number. Okay, it's got to be the exact same number. So when you get the square root of a negative number, this is not possible. So your answer here is, well, there's no real answer. No real answer. Okay? Or you could put not possible or something. So your answer for number 3, actually, there isn't one. No real answer is what you would put for a problem like that. All right, I want to show you one more. I'm running out of space here. This is the bottom of the page. Number 4, 3 times x minus 3 squared plus 2 is equal to 26. Okay, so if I covered up this 26 and I told you to evaluate this side of the equation when x was 100, just picking a number. Okay, we still want to get back to x. Okay, so we would think about our order of operations. The first thing we would do would be subtract 3, then we would square, then we would multiply by 3, and then we would add. Okay, those would be our steps. To solve it, we just work our way from bottom to the top. Okay, so we would get rid of the adding 2 by subtracting 2, so we have 3 times x minus 3 squared is equal to, if we subtract 2, that gives us 24. That would take care of that. To get rid of the multiplying, we just divide, so it'd be x minus 3 squared is equal to 8. That takes care of the multiplying. To undo the squaring, we would take the square root of both sides, so we'd have x plus 3 is equal to plus or minus. Now, square root of 8, we could rewrite that as 4 times 2. So the square root of 8, or square root of 4, sorry, is 2. Then we have the square root of 2. Okay, I'm just simplifying that square root, so that takes care of that. And then the last thing we would do to get rid of the subtracting, sorry, I don't know why I wrote plus 3 there. This should be minus 3. To get rid of the subtracting 3, we would add 3. So plus 3, plus 3. Now, if you want to write it over here, that's fine. I would recommend writing it in front of the plus or minus. Okay, that way there's no doubt where the end of the square root happens, because sometimes people like to extend that square root a little farther, or it's just a little unclear if this plus 3 should be under there or not. So you've got 2 different ways to write this. You could write it as, and I'll write in different colors here, you could write it as positive 3 plus or minus 2 square root of 2, or you could write it as plus or minus 2 square root of 2 plus 3, and be very clear. And you can even put like a little ending bracket on that square root to be very clear that the plus 3 is not part of the square root. So this is the same answer written 2 different ways. So you wouldn't need to write both, obviously. Just write one of the 2. I would prefer the one in blue. That makes the most sense. It's the clearest to most people or to everybody. So try to get in the habit of writing it this way. but this way is not incorrect either. All right, so that's enough of method 1 with square roots. It's time to move on. Method 2, solving by graphing. What we're really looking for is we're looking for the graph's x-intercepts, and we've already done some of that in chapter 2. We were doing the zero function. We're going to be doing the same thing with the calculators, okay? And really, when we're solving by graphing or solving anything, is really we're looking for the graph's x-intercepts. If you were to graph, let me give you an example. If you were to graph, let's say, well, let me go back a little farther. Let's say this one. Okay, negative 9x squared plus 36. If you were to type this in your calculator, what you would find is that the graph crosses the x-axis at positive 2 and negative 2. Really, that's what we're finding every time we solve an equation like this, is we're finding the x-intercepts. Sometimes it doesn't do us a lot of good to use square roots because, you know, maybe it's got that x term in it with x squared, or it's not something that has a nice square root. So sometimes the calculator can be a very useful tool to do this. So to use the graphing calculator, we're going to have to graph the function, and then we'll do second calc or second trace, I guess it would be, and then number 2 where it says 0, and we'll do the left bound, right bound. Hopefully that still is a little familiar. I'm going to try to talk you through this, these examples without the calculator. Hopefully we can discuss it a little more in person, how to do it if you're not sure. Okay, so number 1, solve by graphing. We're going to have x squared minus 8x plus 12 equals 0. Now, in order for this to work with graphing, it's got to be equal to 0. If it's not equal to 0, all you need to do is use your algebra skills to move everything to one side. I would recommend keeping x squared positive, trying to get in that habit. It'll make more sense as we go down the road here. But try to keep this x squared term positive, and then it's going to work really nicely. When you do this, the graph should look, something like this. That's just a rough sketch. I'm just kind of making a real rough sketch. I'm not really sure exactly where it is, but if you use your calculator to find this point and that point, what you're going to find is that your x values are 6 and 2. Those would be your answers for number 1. Again, if you're not sure, these are the steps you're going to do it. Graph it, second trace. Option 2, do your left bound, your right bound. You'll have to do it twice. Do it for one of the intercepts, then do it again for the others. Don't do left bound over here and then right bound over here. It's not going to give you the right answer. Do left bound, right bound, and then left bound, right bound. Okay, so make sure you're going to have to do it twice. All right, number 2, we're going to have 4x squared minus 12x plus 9 equals 0. Again, it's equal to 0. This one, if you were to sketch the graph, would look something like this. What it looks like is that there's only one place where it crosses the x-intercept. That would be where the vertex occurs. If you want to do the x equals negative b over 2a, then you could do that. Again, you could just use a calculator here. There's only one answer here, and that would be 1.5. And number 3, let's try 1/2 x squared equals 6x minus 20. This is a perfect example of it's not equal to 0, but we need to make it equal to 0. And like I said, let's try to keep this x squared term positive. So let's move the 6x over to the other side by subtracting it. We'll also move the 20 by adding it. So minus 6x plus 20. So what we're going to have then is 1/2 x squared minus 6x plus 20 is equal to 0. And once it's there, this is what we're going to type into the calculator. This one, if you were to sketch it, or if you actually graph it, it's going to look something like this, where it doesn't cross the x-axis. And if it doesn't cross the x-axis, what that means is that, well, there's no answer. There's no real solution. No real solution. If it doesn't cross the x-axis, it doesn't have a solution. So if you were to graph, let's say we did one of those earlier that had no solution, this one here. If you were to graph this function, what you would find is that it wouldn't cross the x-axis, and if it doesn't cross the x-axis, it has no real answer. Okay, so that's how the two are kind of related. The third method, factor by group, or solving by group, factoring, sorry. That'll be in the next video. There's some other tidbits that we need to discuss in that as well. So methods 1 and 2 in this video, and then method 3 in the following.